Okay, hi everyone. We're still here in section 12.3, talking about the dot product, one of two types of vector multiplication. Okay, so here's a theorem that the dot product actually will give us something very useful. So the angle theta between two non-zero vectors u and v is given by the following. The cosine of theta, that angle that's between two vectors, so here's a picture. If I have the vector u and the vector v, what I mean by the angle between them is that we're assuming that their initial points are at the origin, so the angle that's between the two vectors here, u and v. That actually ends up being the dot product of u with v divided by the length of u times the length of v. So that's the cosine of the angle, which means that the angle itself, theta, is the inverse cosine of u dot v divided by length of u times length of v. So this is a quick proof using the law of cosines. I don't know if you remember. So if I call this side, which is the u minus v, right? If I take u and then I subtract v, which would be go this, take the initial point of v, but put here, but I want to go minus v, so it's the opposite direction. Then u minus v would be here, but we can also put it over here. So this is another way to draw u minus v. Okay, so let's call that w. Now by the law of cosines, the length of the side opposite the angle we're working with, so the length of this guy squared is equal to the length of the other two sides squared, added up, minus 2 times the length of u times the length of v times the cosine of the angle between them. So that's the law of cosines. You usually see that in trigonometry in high school, or hopefully in pre-calculus, or somewhere you saw it. If not, that's just called the law of cosines, well-known law. So now what I can do is I can solve for cosine of theta, right? So I'll bring this minus 2 uv cosine theta over this side, subtract w squared on this side. So, and then it's just a matter of looking at what this means. What's the length of u squared? So the length of u squared means you take the length of u, which is u1 squared plus u2 squared plus u3 squared, under the square root, but since I'm squaring, I don't have the square root. So the same thing as the length of v squared. Then I have to subtract the length of w squared. But what is w? W is u minus v. So how do I do u minus v? It's u1 minus v1 in the first component, u2 minus v2 in the second component, u3 minus v3 in the third component. So take the length of that vector, you square those components, add them up. Since I want the length squared, I don't have a square root. Okay, I can simplify this greatly by foiling each one of these, right? So u1 minus v1 times u1 minus v1 is u1 squared minus 2 u1 v1 plus v1 squared. Same for this guy, same for this guy down here. And you can see all of these terms cancel out. And what I'm left with is minus a minus 2 1 u1 v1, so that's that guy, minus a minus 2 u2 v2, so that's that guy, and minus a minus 2 u3 v3, so that's that guy. So in other words, 2 times the length of u times the length of v times the cosine of theta equals this right here. But that is 2 times the dot product of u and v. So if I solve for cosine of theta, I get u dot v over length of u times length of v. QED, quod est demonstratum. It has been shown. So example 10, if I want to find the angle between two vectors, I first of all find the cosine of that angle, which is u dot v divided by length of u times length of v. So take the dot product of u and v, it ends up being minus 4. Take the length of u, multiply it times the length of v. You get square root of 9, square root of 49 is 3 times 7. You get minus 4 21st. So theta then is the inverse cosine of minus 4 21st, which is, we know, in the second quadrant, right? Cosine, remember, for the inverse cosine to exist, it has to be between 0 and pi, or 0 and 180 degrees. So this comes out to be 1.76 radians if you have your calculator in radians mode, or 100.98 degrees if it's in degree mode in the second quadrant, because we know the cosine is negative in the second quadrant. So a quick important note there, since u dot v is u1 v1 plus u2 v2 plus u3 v3, which is length of u, length of v times cosine of theta, the angle between the two vectors, we can quickly tell if two vectors are orthogonal. So that word orthogonal means perpendicular. In mathematics, we use the name orthogonal. How do we quickly tell if two vectors are orthogonal? We take their dot product, and if we get 0, that means that the cosine of the angle between them is 0. Well, what angle has a cosine of 0? It's pi over 2. So in other words, the two vectors would be at 90 degrees to each other, or perpendicular, or mathematically we use the term orthogonal.